using simulation, you can get answers much quicker than if you would go to the lab and set up everything. So as I said, it's very time intensive, resource intensive, but on a PC, you can get answers much more quickly, right? You do not need to be a simulation expert actually to use this, right? So it's easy to use and very accessible. And I guess this is one of the reasons why it's so popular.
This is the Podcast for Engineers, the podcast you just have to listen to if you're interested in what's going on in the semiconductor market. Today I'm talking to our guest, Paul Sochor, who is a principal engineer for Power Electronics, Simulation and Modeling. Paul, thank you for joining me.
Thanks for having me on the podcast.
We're so happy to have you because IPOSIM and simulation is one of my favorite topics. And we just had a new release for IPOSIM called IPOSIM SPICE, where we integrate SPICE models to give our customers a little bit more flexibility in their design process. But before we get into what's new about IPOSIM SPICE, I thought we could take it back a bit to the very beginning and how you could explain a little bit about how engineers have been simulating before IPOSIM and simulation, virtual simulation.
Yeah, so simulation is actually a very deep topic, and it requires quite a bit of understanding and know-how. So it's not as easy as it might sound that you just install some program, download a model, and then you start running your simulation and get results which actually help you. There's actually quite a learning curve there. And one of the, let's say, benefits of IPOSIM is that it is relatively easy and accessible to many engineers. I mean, there's a lot of, let's say, electrical engineers out there which have a lot of very deep understanding on the circuitry and on the devices, but maybe are not simulation experts. Right, and for these users, IPOSIM is actually a relatively easy to use tool where they can basically check the device performance under different conditions in various application conditions or application circuits. And get ideas about how the device they're looking for example, would be performing.
Okay, so basically simulation is then a virtual lab environment, kind of replacing as we go to a more digital society and our work becomes more and more digital. We're taking this trial and error that used to happen in the lab and putting it in a computer.
Yeah, exactly. So, I mean, these engineers I talked about, right, who have a lot of know-how on the circuit and applications, right, but without being, let's say, simulation experts, what they have been doing so far is basically they have been building up prototypes in the lab, right, with various devices and circuit configurations, and they have been measuring this and debugging this and evaluating this, and that is how, let's say, the classical power electronics circuit development has been done for the past, let's say, 30, 40, 50 years. So it was...
Okay, it sounds pretty time consuming though, right?
Yeah, it is. I mean, a lab, and first of all, you need a lab, right? You need a lab which is equipped, and very often these kind of lab setups are extremely time consuming because you really need to, it's not just that you need a circuit, you also need controllers, you need to have a proper measurement setup. So on one hand, it's very resource intensive, right? That you need a lot of equipment, but it's also very time intensive, right? Like characterizing devices in a lab setup takes a lot of time. And
okay,
now
so engineers are actually just building prototypes of a real system and testing it. Is that what you're saying?
Yeah, I mean, let's say if it's a full, there are different stages of how somebody like a development engineer would work. I mean, for example, if he wants to evaluate the device performance or power semiconductor performance, he would likely not build up a full-fledged system with everything, but he would start maybe with a certain part and then evaluate this part, right? And then once he is satisfied, he would go to the next level and include more components. And in the end, you would test the whole system, right? Yeah, but all of this is quite time consuming, right? So it takes a lot of time, resources, and yeah, I mean, it's just these days the development cycles have to become shorter and shorter. So you need to get answers much faster than that.
Okay, so you really described simulation at its basic level in a lab. What's the next step? What's the first integration of digital tools when it comes to simulation?
So there are different levels where you can simulate, right? So you can simulate more on the power semiconductor device level, then you can simulate more on the, let's say, circuit level, and then you can simulate more on a system level, right? Like the system level would, for example, be when you have a solar inverter, would be, for example, that you include things like a grid connection and the PV panels and including all the controls. The device level would be to see how the semiconductor device is performing under, like inside its a power conversion circuit. And then let's say, for example, what is in between this what I usually like to call circuit level simulation. There you include more things like filters and maybe also parts of the controls, but you might not simulate. You would only simulate a certain amount of time, not the fully fledged circuits system simulation, which really includes everything.
Okay, why would engineers need to simulate?
I would say there's various reasons, right? First of all is using simulation, you can get answers much quicker than if you would go to the lab and set up everything. So as I said, it's very time intensive, resource intensive, but on a PC, you can get answers much more quickly, right? Especially when you want to see how your device or circuit is performing under different conditions. So if you want to do parameter sweeps and so on, doing this in a lab environment is typically very, time and resource intensive, right? So it gives you results much quicker, but also you can very often in the lab, you're not really sure whether what you're really measuring is really true or not. So the simulation also gives you more, it gives you more a kind of, how is it called?
Like an accurate
kind of,
or real world?
Yeah, kind of a check. I mean, whether, because it's more ideal conditions, right? And you can really verify the circuit under ideal conditions, but you can then also, of course, go one or two steps higher where you include more and more influences, right? So for, also debugging purposes, this is very nice because you can see how the device or your circuit is operating under various kinds of conditions, without actually generating these conditions in the lab. So very often this is difficult, right? So for example, when it comes to temperature, right? So devices are characterized at 175 degrees. So doing this in the lab is of course not so easy, but in simulation, it's no problem at all.
Okay, so it really gives you more control of the environment and all of the aspects that you want to test for.
Exactly. And also, of course, there's also other types of, let's say, use cases. For example, certain types of tests which are let's say, destructive or so. For example, short circuit tests and so on. So these kind of tests, if you do them in the lab, it usually means that either the device is destroyed or maybe part of your setup. But in a simulation, you can do whatever kind of these destructive tests you want to do, and basically the device will never fail in a simulation, right? So
without the fire alarms going off.
Exactly, yeah. So it's much safer and easier to do these kind of special types of simulations, which otherwise would be very tedious to do in the lab.
Okay, so tell me about IPOSIM. So IPOSIM at Infineon has been around for many, many years. It's a favorite. It's widely used. Tell me a little about IPOSIM before we get into the new IPOSIM, IPOSIM SPICE.
Yeah, so IPOSIM is our Infineon online simulator, application online simulator. So it allows for evaluating the performance of different power semiconductor devices. So, for example, silicon IGBTs, so discretes and modules, silicon carbide, MOSFETs. And you can evaluate the performance of these devices in various types of application circuits, right? So, for example, three-phase inverter or soft switching, DC-DC converter. So we have different types of circuits, and you can basically select a device and evaluate how this device would be operating in this kind of circuit environment. And it's very easy to use, right? So this is one of the, let's say, selling points, that you do not need to be a simulation expert actually to use this, right? So it's easy to use and very accessible. And I guess this is one of the reasons why it's so popular.
Okay, but IPOSIM SPICE comes with an added layer of detail, right?
Exactly.
Integrating SPICE models.
Yeah.
Okay, tell me a little bit about that.
Yeah, exactly. So let's say the device models which are included in our, let's call them classic IPOSIM, they are based on datasheet conditions and the values which are specified in the datasheet. Now, one thing which is important to understand is that the conditions which are specified in the datasheet, they have been, let's say, measured in a lab. So these are kind of lab conditions, so under, let's say, ideal conditions, right? And usually, like when the customer or the user is buying the devices and using them in their, let's say, own application, for example, switching energies which are stated in the datasheet, they will likely be different, and also the switching performance in his own application. And the reason for this is that power semiconductor devices are extremely complicated, and they have a lot of dependencies. The performance depends strongly on the circuit conditions and on the operating conditions, right? So if you have a different type of operating condition, then of course the switching behavior will also be different. And this is one point where we try now to, let's say, fill the gap, right? To offer customers or users, more flexibility in adapting the conditions in the simulation to their own application conditions.
Okay, so for an example, one of our customers may have an application, an EV charger or something that's in a humid condition with different temperature variations. Can you explain a little bit how they would use IPOSIM SPICE to simulate that?
Yeah, exactly. So, so what you can actually influence in IPOSIM SPICE is the operating conditions of the semiconductor device. So as I mentioned, the standard IPOSIM models are based on datasheet conditions. So there you have typically one gate voltage, and the values are specified under certain strain inductance and dead time and gate resistance. However, now the customer or the user, they might want to use this power semiconductor device under different conditions, right? For example, different gate voltage. He has a different stray inductance. He wants to use a certain gate driver. He wants to have a certain dead time. And all of these circuit and operating conditions you can actually input, into the GUI, and then have the simulation run under exactly these specific conditions, right? So the customer can compare, how much is the performance actually changing when I change certain operating conditions, right? So this is something which was not possible so far with IPOSIM. But now with IPOSIM SPICE, this becomes possible.
Okay, it sounds like a lot of different flexibility. For what products do we have IPOSIM SPICE available?
So at the moment, IPOSIM SPICE is available for silicon carbide discretes. So these are the products where we are starting with. However, like in the upcoming months, we will also include other power semiconductor devices, such as modules. And we also want to include silicon MOSFETs, silicon IGBTs. So we want to extend the devices which are supported to basically the whole power semiconductor portfolio which Infineon is offering. One more thing. So one thing which is also special is that with IPOSIM SPICE, it's also possible to select specific gate drivers, right? So we at Infineon, we have a very broad portfolio of gate drivers, and these gate drivers have a large influence on the device behavior. And the user can select different gate drivers, according to their application needs, and compare the performance using these different type of gate drivers. So the release, we are starting with, I think, around 35 gate drivers, but also here we will extend this to the whole Infineon portfolio in the future. So that's our plan.
Okay, really exciting. And before we wrap up, I wanted to ask a little bit, in case it's not clear for some of our audience, when would someone choose IPOSIM versus IPOSIM SPICE, or vice versa? When would someone really need IPOSIM SPICE rather than IPOSIM?
Yeah, very good question. So the standard, let's say IPOSIM, is more for rough product selection, I would say. So just to give you an example, so for silicon carbide 1200 volt, our Gen 2, I think we have in one package around 30 different products. And very often it's not really clear which product to choose from. Or let's say if you want to compare like silicon carbide with an IGBT, to get a rough estimation, how would these device perform in my application, you would go with the standard IPOSIM. But then let's say if you want to have more custom tuning, right? So you have more specific conditions in your application, and you want to see how the device which I selected would be performing in my application, then you would go the next step with IPOSIM SPICE, where you can have all these customizations, which then will give you more, let's say, accuracy or more detailed picture.
Okay, so maybe the first step in designing would be then the regular IPOSIM, just to get a good idea for what products fit.
Exactly.
And IPOSIM SPICE is then the next layer. Okay. Where can our customers find IPOSIM SPICE?
Yeah, so IPOSIM SPICE is part of our IPOSIM simulation platform. It's integrated in the standard IPOSIM, and currently all the models all the products which are supported by IPOSIM SPICE, they are marked with they have a chili icon, so you can easily identify them. So at the moment, as I said,
spicy chili.
Exactly. So at the moment, it's only the silicon carbide devices, the discretes, which are supported. But now when more and more devices will be included, you will basically be able to identify them by checking for the chili icon.
Okay, Paul, thank you so much for being here and walking us through the latest developments of IPOSIM and the world of simulation at Infineon.
Yeah, thanks a lot for the opportunity being on the show.
And to our audience, if you are interested in IPOSIM, IPOSIM SPICE, or any of the other simulation tools we offer at Infineon, please visit our website, or I'll also leave some interesting links in the show notes below. And for future episodes, stay tuned. We've got a lot more to cover on power semiconductors.